Welcome to the addition rule. We are continuing to count things. So we've talked previously about cardinality of sets within the roster notation. We've talked about the cardinality of sets using Venn diagrams. And this is going to heavily incorporate that idea of cardinality, the idea of counting sets. In particular, we're really going to rely on our understanding of Venn diagrams with two sets. So please make sure that you've mastered that content before you continue. The addition principle for categories. All right. For two disjoint categories, if we have M ways of doing one thing and N ways of doing another, and we can't do both at the same time, then there are M plus N ways to do one action. So let's consider shoes. All right, you've got 3 pairs of cowboy boots and you have 2 pairs of sneakers. So if you were to go into your closet and say, okay, how many different ways could I choose a pair of shoes to wear today? It would just be 3 plus 2. The 3 cowboy boots plus the 2 tennis shoes. And so you'd have 5 options. And the reason this is disjoint categories is because you cannot wear your cowboy boots and your sneakers simultaneously. Another instance, if you go to the fabric store, Moody Fabric Store has 3 types of plaid fabric, 4 colors of solid fabric, and 2 choices of polka dot fabric. How many ways can Sam choose a fabric? Okay, so Sam is at the fabric store and Sam is only gonna buy 1 cut of fabric. How many options do we have? Well, none of these categories overlap, and this is not an arguable point, okay? The plaid is plaid, polka dot is polka dot, solid is solid. Don't tell me there's a solid polka dot. I'm not buying it. So you've got the 3 from your plaid, the 4 from your solids, and your 2 from your polka dot. So if you add those together, 3, 4 with 2 is going to be 9 choices for fabric. Let's formalize this idea using a Venn diagram instead of shoes and fabric. Okay, so for two disjoint sets, A and B, if A has M elements and B has N elements, then the set A union B, you could just simply add them. It has M plus N elements. And the reason you can do this is because the sets are disjoint. There is no overlap. So you're not in danger of double counting anything. So if I were to label my Venn diagram here, I would write the cardinality of A is M, the cardinality of B is N, and then the cardinality of A union B is simply the cardinality of A plus the cardinality of B, so M plus N. This is the mathematical, formal, notation-heavy way of writing what we just said in the above sentence.